at least you guys get something out of it. We got a couple points to talk about at the end. There's some lessons learned, some take homes, that type of stuff. So with that, I want to thank the APWA for putting this little lecture on and letting me come on here and talk to you guys for a bit. I've been trying to submit to an APWA conference or a lunch and learn presentation for the last couple of years, and this is the first one that I've got. So I'm glad to be here. I'm happy to talk about this stuff, and I hope you guys enjoy. So I want to start off, talk about me here for a little bit, who I am. So I'm from Oregon here. I grew up in the Roseburg area, just south of Salem here where I'm at now currently. I grew up doing some residential commercial framing. I moved on from that and went into some heavy equipment operation stuff, worked in the woods a lot. I worked for Roseburg Forest Products and Oregon Department of Fish and Wildlife doing stream restoration projects. Built a lot of roads, a lot of miscellaneous log jams and rock weirs and different stuff to try to help some fish spawning habitat. Went to Oregon State University after getting a transfer degree from Umpqua Community College, graduated with my bachelor's in civil at OSU, go Beavs. How about them basketball boys? They did really good. After I got out of OSU in 2018, I applied at Keller Associates here in Salem. They were looking to expand the team, needed someone with some construction experience and was willing to help out. And I've been here ever since, now going on almost 3 years in June. It's hard to believe how fast it's gone. And then the stuff that when I'm not here in the office, I'm out in the woods all the time. I do a lot of hunting, fishing, camping, riding motorcycles. In the winter, I'm out snowmobiling, that type of stuff. So lots of fun. Try to live and play here in the Northwest. I'd like to stay up here. A little bit about Keller Associates and who we are. We're a full service engineering firm, multifaceted. We've done all kinds of projects all over the Northwest here. We have 7 offices throughout Oregon, Washington, Nevada, Idaho. We've been around for a little over 25 years now. I think it's 27 this year in the Pacific Northwest. We've delivered trustworthy and quality engineering solutions to clients of all sizes over the last several years. We're employee owned, have over 120 problem solvers on staff. Where we really excel is combining local and regional perspectives along with our strong technical skills, collaborative approaches to deliver transportation infrastructure projects for both state and local agencies throughout the Pacific Northwest. We focus a lot on smaller communities that really need help. We really help them out the most by acquiring funding. That's kind of our big thing, is that a city will come to us, say, hey, this is what we want to do, but we can't pay for it. How can you help? And that's where we really like to help the most. We have our Salem office here. We have a little bit of everything in the engineering department. We've got transportation, water, wastewater, stormwater, and environmental engineers. And then we have a structural, surveying, electrical, and controls group over in our Meridian office in Idaho, where our main headquarters is. But just because they're over there doesn't mean that we don't talk to them daily. I mean, the way technology is these days with Teams and Zoom, it's no different from walking across the hall and talking to someone about a project. So it's really helped our collaborative ability here at Keller, and it's been a lot of fun to work here. So starting off with the project history a little bit. So those of you familiar with Oregon, I'm sure you know where Eugene is. Lane Community College is there. That's where their main campus is, right off I-5. They had some issues with their accessibility they have on site. A lot of their pedestrian accessible routes were not accessible. Their ramps were old and outdated. They needed a lot of help. Primarily their handicap accessible stalls and van accessible parking stalls were not up to the required quota that they needed. So they realized this. We realized it's going to be an issue. So they wanted to get away on it really quick. So it led us to have a really accelerated schedule to try to get everything done and designed in 1 year, and then get it out to construction in the summer. It being a school, all their students are primarily gone. So in the summer would be the best time to get all the work done. We didn't want to have work in parking lots when their parking lots are usually full of students. And then them being a little private school, they didn't have very much money. So their limited construction allowance or maintenance budget every year really kept us in our bounds as far as what we could do with the money that we had and the time constraints that we had. So kind of the stuff that we talked about. So the limited budget that we're discussing here is about $150,000 a year for a total maintenance budget. They were looking at doing 2 years worth, so we had about 300,000 total for survey, design, construction, admin, all that stuff. So pretty small for the size of the project that we're doing here. When we started looking into it and the scoping, we realized that, okay, if we're going to have a full topo survey of the entire campus, you're looking at upwards of $30, $40, $50,000 for a full field survey of all their ramps, all the walkways, all the parking lots. I mean, they've got 14 main parking lots and a lot of smaller ones that are sublots. So when we started looking into that, we were like, yeah, we could probably cut some of the topo out, but we don't really want to shoot ourselves in the foot by neglecting to survey areas that we may need later. So we would most likely want to survey everything, so we had all the information at one time we could go through our design. Talking with the client on that, spending upwards of a large piece of the pie of their funding on just a survey alone without us even doing any work wasn't really in the cards. So we decided we stepped back from that. We got away from surveying. We thought, well, hey, we could go out there and just look at the site and do everything in-house without a topo survey. The site's relatively flat. That's why we felt really comfortable doing this. Water wasn't really an issue. So what we ended up doing is we scoped it out, got an agreement set up. We spaced out 2 site visits. So this is kind of where the presentation really starts of how we did this entire thing. So we said, all right, we need to have 2 site visits. The first was to collect all of our photos, the measurements, take good notes, all that stuff, where we know that we wanted to, because no matter how good we are, we're going to miss stuff. So when we're out there the first time taking photos, videos, all that good stuff, when you're back in the office and you're working on stuff, you're going to say, oh man, I really wish I had that photo. I really wish I had that measurement. So we went out there full force. We took 3 days, Friday, Saturday, Sunday, a 2-man crew, walked the entire site with the client, talked about all their locations, what their priorities were, came up with a plan of attack on what areas that we specifically wanted to focus on, went back to the office, did a lot of our sketching in Google Earth to begin with. And then once we got everything that we thought that we needed, we made a list of the things that we didn't have, went back out there one more time, spent 2 days with a drone, flying and capturing aerial images that were a little more detailed than what we could find on Google Earth, and then taking all the additional measurements and things that we missed in the field that we would have liked to have to really round out our design. So that being said, I mean, our survey was photos. All measurements were taken with a tape measure, a wheel, and a digital level that you use to inspect ADA ramps, like if you're doing ODOT inspections. So something to be said is you can never take enough photos and videos. Cyberspace is free. Just load it up. You can take as many photos as you want. You'll never know what you need until you're back in the office. So take multiple angles, all different videos from different sides of curb. There's something on one side of a tree that you didn't get. Go to the other side of the lot, take more photos. It's free. So get as much as you can. So after we did all of that, we tried to take as good a notes as we could, and then went back to the office. Many of the lots on the main campus needed improvements, pretty much all of them. So we looked at the data and the photos and everything that we had, came up with a plan of attack, had a little meeting with the client, talked with them about, okay, what areas do we want to focus on the most? We collaborated with them and identified problem areas, and then went into kind of into our 30% design next, or our tech memo first. But something to be said is a lot of this is it can't be done without a really strong knowledge of the ADA accessibility guidelines and the slopes and what you need, where the caveats are, what you can get away with, what you can't. So you're going to need someone that is really comfortable with this stuff and has quite a bit of experience with it. But if you've got the right team, these projects are totally doable. We know you hear about how picky ADA projects are because of the slopes, and there's no tolerances, and it is tough. But if you know what you're doing and you got the right crew on it, and you get a decent contractor that has done this before, which most contractors have these days, you can get really successful projects for good prices. So after saying all that, before we wanted to dive straight into a 30, 60, 90, 100% design, as we went on through, we said, okay, we've got all these really good ideas, we've got really good notes and photos, but before we actually go into a design, let's get our thoughts down on paper first. So we generated a tech memo to begin with. So we said, okay, we divided it all out by all the different lots. We identified where all the problem areas are, why they're why they're underserviced or what the deficiencies are. And then we talked about, okay, what we need to improve, how we're going to get there, came up with a linear bulleted plan of attack. And then once we got buy-off from the client on that, we talked about it, said, hey, you know, I don't really like this. Can we do this over here? Can we move some stuff around? We said, yeah, sure, or no, this is why. And once we got something that we both agreed on, then we felt really comfortable moving into design, and the design went a lot quicker, knowing that we had vetted out all of the problems via a tech memo before even a 30% design. So that's something that really helped us out, worth commenting on. So starting out, where your design starts for us, you know, typically when you have a survey, you've got your full surface out there, so you know where to start, you know where your constraints are, and you can work inside that boundary. When you don't have that, really you got to start with the big things and then narrow them down. So we started with the PROAG, which is for those of you who don't know, is the public right-of-way accessibility guidelines requirement through ada.gov. So they're the U.S. government's main guidelines for all accessibility guidelines within the public right-of-way. So in there, under one of the chapters, under the parking facilities, there's this lovely table there that's on the left side of the screen. So what that talks about is, it says, okay, like on the fourth row, it says if there's 76 to 100 parking stalls at this facility, 3 of them need to be a standard handicap accessible stall, and 1 of them has to be a van, which has a wider do not parking area next to the stall. Instead of 5 feet, it's 8 feet. So really, when you have 100 stalls, you really only have 96, because 2 of them have to be ADA compliant, van accessible, that type of thing. So we started with going down to every lot and all 14 lots and all 20 something sublots, and we counted all the stalls, and we said, okay, based on all these stalls, the total number, this is how many standard and van accessible stalls that we need to have in each lot. So then that gave us the baseline for the number of stalls that needed to be constructed across the entire project. And then we looked at how we could fit those in on each lot and design basically outward from there. So we said in the PROAG, right after this table that's here, there's another table or another paragraph that says, you know, wherever that you place these facilities, you know, common sense is you want to make it accessible. So you got to put it basically right in front of the building or right in front of the facility that these stalls are leading to. So we attempted to do that on as many lots as we could, but there's going to be cases where that's not possible, based on mostly cost, because when you've got a lot that has quite a bit of slope, and when you're doing these stalls, they have to be less than 2% max in any direction. It doesn't make sense to tear up a big area and do basically a retaining wall around a parking stall when 50 feet away there's a big flat spot that would work really well. So when we found locations like that, you just kind of compare the worst of both worlds and come up with the best situation that you can. And I think we only had 1 stall in the entire area that we actually had to make an accessible path to get to a flatter area, because it made more sense. It was wide open, it was safer, it was flatter, it was away from a truck route, things like that. So then we'd say, okay, once we got the stall locations identified, we started assessing the sidewalk and the roadway around it, looking at the slopes and along the stalls, or where these stalls need to be, figure out what type of improvements that we need to make for the accessibility to get from the sidewalk to the building and to the parking stalls and vice versa. So it was a lot, especially on a limited budget. So using the tech memo as an outline, we went through trying to minimize our footprint as much as we could. You know, the less material you got to take out and put back in, the more money you're going to save. So budget and schedule was really driving our whole design here. So like we said before, we use Google Earth for a lot of the concepts. So up to like the first half to almost 2/3 of the 30% design, we stayed in Google Earth for our preliminary layout. Reasonings for that is because Google Earth has some really awesome area measurement and elevation features that really benefited a site layout where we didn't have any elevations at all. So even though this isn't survey accuracy, and we understand that, any type of elevation at all really helps. And you can even draw paths in Google Earth if you're not aware, and you can actually cut profiles across your areas. So we did that for a little bit. Once we felt really good about the layout, we gave our sketches to the talented CAD staff that we have, and basically just cut them loose on the design and said, this is what we want to do, figure it out, get the measurements in there, based on our scaled drawing from drones, which I'm going to talk about next. And then they came up with any conflicts or issues that we had, but we primarily just let them go. And then as they came into issues, they just let us know. So that being said, some pro tips when doing this photography, especially with drones. One is to always stay directly above the area that you're photographing. If you get any kind of skew at all, like this slide here, you can see how it's kind of at an angle there. That is going to screw up your any type of dimensioning or scaling that you want to do for this for that lot. So that being said, you want to be directly above it the best that you can, and then try not to zoom in super close, because the fisheye of the lens will still flare out your edges. So if you get up a little bit higher, if you got a high enough quality drone, you can still zoom in, get some decent plans, but without while maintaining the integrity of your photos. Something else that really helped, you put a tape measure on the ground, scale out 10 feet, 5 feet, or use some paint and make out some kind of scaling to make a grid that's easy to remember. So when you do this a month later in your CAD, you can remember what those are. But you just bring your photos into CAD, then you can scale your photos based on that 10 foot or 10 foot or a 5 foot measurement, whatever you put on the ground. And then you have photos that are really accurate. Honestly, they're pretty close to scale as long as you took the photo directly above it. It really helps out a lot, especially in the quantity takeoff portions of the work. Nowadays, we have software that does all that for us. We can basically plot a path and the drone will fly everything automatically, put it into our drone software that we have, and it'll build a actual like photorealistic survey quality aerial that we can use. But that stuff wasn't available in 2016, 17 when we did this project. So once we got the photos in, everything in CAD, we let them go. I mean, 30% to 100% is pretty generic design. You go through up to a 50 or 60% submittal, but your plans, cost estimates, specs all together, send it to the client, do the reviews, the normal stuff. So that was basically our whole theory up to 100% on the design side of what we did and how we got there. So writing the specifications was another part that we knew was going to be super important, more so important than typical projects that you do, just because of the liability and risk of not having a survey on a project. There's really no control or anything. The contractors has a lot of variance on, well, my interpretation of this or that is this way. And if you don't have good specs, then you're not really going to have good teeth to fight back on if mistakes or disputes show up later during construction. Our general structure for our specs were on unit price work. It made more sense than doing a lump sum, something that we don't have direct measurement and quantity besides what we did in our field measurements to do our estimated quantities in our bid schedule. If we were going to do a lump sum basis, every time that something was a little bit off, either it washed out or if it was a lump sum project and there was a quantity that was off enough, the contractor could dispute it. We'd have to go through contract change orders and slow everything down. When you have a unit price project, if it was 100 tons or 150 tons of rock, you just up the quantity, and then at the end of the project, you do one change order to adjust your final price. So that made work a lot easier during construction, as far as managing the contract, managing the price, and also managing the percent complete. When you have a lump sum project, it's really hard to figure out what percent complete you are because you're basing it on funds. So every month you get an invoice and you say, okay, that invoice was 20% of the total, so we must be 20% done. But when you're doing a unit price project, you can bring it out daily or weekly or bi-monthly, to where when you say, okay, we've got 50% of the curb installed and 10% of the concrete and this and that, you just do a weighted average and you can tell daily what percent complete of the contract you are. So it really makes tracking the contract construction a lot easier, easier to update schedules and track that type of stuff if the client's really interested in tracking schedules. Those of you that don't often work in specs, or those of you that do, I'm sure you're aware, but if you don't, it's always a good idea to have some language in there that says something like the estimated quantities shown in the bid schedule are not guaranteed. They're solely for purposes of comparison of bids at determining the original contract price. Any of the unit price work that will be based on actual quantities installed and constructed, not the estimated ones that we have in there. Pretty generic language that'll be in pretty much any unit price contract, but it's always good to verify that you have that. Something else that really saved us at one point was having language in The agreement and the bidding documents, the advertisement to the bid advertisement, and at the pre-bid meeting, which we made mandatory, was that we said this is a field fit project. We said that there is no survey on this project. That way, when it came back to us later, which I'll talk about at the end of the presentation, when they say, well, this was a lot more work than we thought it was going to be, we didn't know that we were going to have to do this, and we didn't know we didn't have survey for that part. You can say, no, it says directly in your contract and at bid time and at the pre-bid meeting that we didn't have survey for this. This, bid a little bit high if you're worried about the risk that goes along with that. So it's a good language to have to set a good baseline at the beginning of the project that, hey, this is not going to be a typical ODOT project or anything, which is what they kept throwing at me during construction. If this was an ODOT project, we'd have survey for this. Well, this isn't an ODOT project, and we told you that we didn't have survey at the beginning. So kind of took that part of the argument out. Really helped. Something else that we did, last two things really quickly, we had an administrative reserve budgeted into the contract amount. We put $20,000 as a hard line in there at the end of the bid schedule that says, hey, we understand that there's going to be unforeseen circumstances as things come up, as we find utilities that need to be fixed, whatever. The contractor can come up with a price, say this is how much it's going to take, and then we can pull that directly out of the $20,000 administrative reserve. Really helped us out a lot. It seemed to help the contractor a little bit as far as they understand that, okay, we're on a limited budget and we basically only have to, when the $20,000 of administrative reserve, which is what we called it contingency during construction, is they understand, okay, 20% is, or 20,000 is all we can go over on this project. We make them assume that there's no more money. So we want to fit within that. So it seemed to help us out on getting prices and them willing to work with us a little bit. Last thing, we had directed surveying in there. Even though we didn't have survey on the design side, we loaded in 16 hours of field survey and 8 hours of office survey for their for building the topo and building their PDF mapping. That helped because there was one lot specifically where we had some issues, and it would have been really nice to have survey, but we had that loaded into the bid schedule at a unit price where we said, hey, call your surveyor, have them come out for 2-3 hours, make a topo of this. So we have a better idea, because some of the grades are really tight and we had some water issues. It was really nice to have a survey for specific locations where it really counted. So all huge things that really helped our project a lot. Once we got through all of that, I kind of got ahead of myself a little bit, but when we got into bidding, this project was designed in 16, put out to bid in 17. Bids came back in, they were about $60,000 higher than the construction or the college's budget for this. So they said, we can't do it. They thought that maybe we'd get lucky, based on our engineering estimate. They knew it was going to be higher than what they had, but you never know. So they threw it out there, came in too high. We said, okay, we got to wait. So they shelved it for a year, got another year's worth of maintenance budget, bid it out in 18, and we got a contractor on board and started doing it. So major difference between a normal construction project and one of these field fit ones is you got to have someone on site full time. So we had a full-time resident project representative, RPR, which was me. This is where I really came in on the project. I was late to the design, but I did all of the construction administration. So I was on site every day, all day. Every day the contractor was there. I was there working in the car, working on this project, working on other projects, whatever I needed to do. Anytime a contractor had a question, I was there to give direction or support or bring the client in to talk about some stuff or change a layout of something, because nothing's going to go according to plan. We know that, but it was, you got to be there. I had to be there. So things that I did while I was there that absolutely saved the project. So one thing, daily diaries. You have to do them. You have to make them very detailed. No shorthand. Do the best that you can. Make the best notes that you can. What you did 15 weeks ago, you're not going to remember. So you got to make sure you write it down every day. Things that I wrote down was who was on site, when did they arrive, when did I arrive, any equipment or material deliveries, what equipment and material was used or installed, what work was started, worked on, or completed that day, what the weather was, and then any direction given to the contractor or direction coming from the owner, any plan deviations, any communications with site foreman or owner. All things totally worth writing down. That way you have it on paper later if it ever comes back to be disputed. Kind of talked about the shorthand. It'll bite you when you're trying to figure out what you were writing. Three words to a sentence isn't really going to save you down the road. Something else that helped me was not waiting until the end of the day to finish my my daily diary. As I was seeing things during the day, when a truck showed up, I wrote it down. When material arrived, when equipment left, I wrote it down. That way, there was no trying to recollect at the end of the day. You know, what showed up, who was here, what subs were here, what wasn't. It's a lot easier to do as you're doing it. That way, you don't have to worry about it. It takes your stress down. Last thing, this is the most important, was every day, at the end of every day, whatever that was removed or whatever was installed, or linear footage or anything, we did daily quantity takeoffs. Because a lot of the times when you remove a section of asphalt, you know, say you remove 5 feet of curb and you put back 7, well, just because there's 7 feet of curb there, you now no longer have any evidence of what was there beforehand, besides photos that, you know, is kind of up in the air of whether they were scalable or not. So what I did every day, at the end of every day, we went around to all the different lots that they were working on. We pulled a quantity takeoff of what was done that day, every day, wrote down all of the quantities for all of the bid items. And then once me and the site foreman said, okay, yeah, that's what we actually did today, we both initialed it. And then I filed that away. And the next day did the same thing. So this helps not only for your project tracking, but also for it gets rid of any disputes later in the day, you know, that, which is what happened to us. The foreman was good with everything that was going on, but they had some issues on the contractor side that when the project was coming to a close, the foreman's boss, who was the project manager for the whole thing, had some issues and some questions about, okay, did we actually really remove that much or install that much? I can say, well, here you go. Here's what your foreman initialed off. This is what we did. And it totally eliminated any issues like that. So that is something that it's annoying. It adds on to your day at the end of every day, but if you it's going to save you later. There's no other way to say it. It's going to save your butt. So just like in the design, when you're field fitting, where do you start? You know, when you have a survey, you can start at your constraints, work your way in. You've got point data in the middle, you can figure it all out. When you're field fitting and you don't have any information, you got to start from the outside, work your way in. So this photo here on the left, we've got this is one of their lots that we tore out. We're replacing everything up to this retaining wall. So we knew, okay, we got 18-foot deep stalls. Let's come back about 21, 22 feet to allow a little transition zone. And then we used the rotary laser, the transit that's shown there in the photo. And we did a couple spot elevations all the way around, figure out what our slopes are going to be, figure out what our constraints are from what we're tying into to a transition from illegal to legal, and then make our legal improvements, and then do all of our finishing work. So sounds easy. That was what we did. We started here, sloped in at 1.5%, made sure that water was going towards the retaining wall. You can see pipe in the background because we had to install some inlets and do some adjustments. Sounds easy. There was a lot more to it than what I just talked about, which is just general construction. You find stuff you didn't know that you had. Things that three things that we didn't know that we had out there. That retaining wall actually isn't a retaining wall. It was actually curb and gutter that was extended height. That was like a 2.5 foot tall curb and gutter. So when we went in there and we saw cut this and we started pulling out all of this asphalt, we didn't saw cut along the back of that because we thought the asphalt would just peel away from it. Well, we found out that once we removed 2.5 inches of asphalt, there was a 6-inch curb gutter there that had to be saw cut. So more time, more issues, stuff that wouldn't be found during survey. So survey wouldn't have helped us anyway. But it just goes to show that whether you're doing it full survey or field fit, you're always going to find problems. This is actually a pro to having an RPR on site because I was there when they were doing it. We discovered it. We had an issue. We got the client on site, made direction that minute, and said, okay, we need to saw cut the rest of this curb out because it was a higher elevation than what we needed. So stuff like that. Something else, buried stuff you don't know you're going to hit. When saw cutting along that out in the road, there was an underground power line there that we didn't know that ran the street lights that were in the background of the photo that was just on screen. So it wasn't marked out. The client didn't know that it was there, so it was really no one's fault. We had the maintenance department from LCC come out. They ran in a new section of pipe. They spliced the wire back together and was good to go. Something else that was out there, underground irrigation lines that were abandoned that we didn't know was there. As you saw cut through those that are full of water starts to come out of them and they fill your ditches. So unnecessary problems that we didn't know we were going to encounter, a little bit of pumping, a little bit of slower digging, that type of stuff to get the ditches cleaned out to prep for concrete. But there'll always be slowdowns, always be unforeseen conditions. So now, getting away from unforeseen conditions during construction, now we'll go, okay, we went from 2D to 3D. No, it doesn't matter how many times that we've reviewed the plans or the clients reviewed the plans or we've done internal quality control checks and reviews, you're still going to miss stuff. So something that we missed, they're all minor things. This was the only thing that we missed on the whole project, is when you're looking at this is a cut of one of our plans on the campus, and it looks fine. It says, okay, we got some ramps here, ramps over here, ramp across the street. We've got all of our 9-foot, 8-foot stalls of inaccessible stuff, pretty straightforward. You're looking at it, looks totally constructible, but these wings don't make sense, because when you're looking at this, the asphalt is flush with the concrete sidewalk, and this ramp is flush with the asphalt out here. So why do we need a wing here? This shouldn't exist, which was something minor, but it was missed in the design. So when we went out into construction, there's no asphalt here yet, so there's a ledge, but this is flush and this is flush out here. So instead of doing a wing like what was shown right here on the plans, we just said, okay, let's just do a full height triangle there and kind of create a path for pedestrians to wander around that. And then once they get to this level spot here, they can choose which direction they want to go. So minor things. It looks good in 2D, looks really good, and you get out in 3D and you're like, oh, well, that didn't make any sense. Other issues that were no fault to anyone's: when you don't have survey, you didn't know that there was an existing water problem out there they had. In the middle of summer, I wouldn't have known this was a problem either, except I just happened to be on this lot during a fire flow test. So the college was out there opening all their fire hydrants and flooded out this lot, and we had this big standing pond of water here, right after all the improvements that we did out there in that other area that you can see is freshly striped. So we had a contractor on site. We said, why don't we fix this stuff? You know, this is something that we would have caught in design, and we would have brought it up to you then to say, hey, let's improve this. How about we have a contractor here? Let's use some of that $20,000 built-in contingency and bill a little bit of that and fix this and improve it. So that was what we did. Apologies for not getting a better photo of that. This is the best photo that I had looking through my records. Basically all we did is I was out there, the contractor was there, and the client was there, and we met on site. We had a little rotary transit laser set up, and we shot all of the grades around the flow line on both sides and the inlets over here behind this trash can. We figured out, okay, we can get all of this flow to work. I drew up a little sketch in the field by hand, and the concrete crew came in, staked everything out. I checked it all with the level, and it was good. They came in, poured it, and now we've got a really nice improvement here for their waterway that uh, wouldn't have would have been caught during design, but something that we just catch after the fact. So some construction pros doing it via field fit with a full-time RPR. So some of the pros, like we've talked about before, basically RFIs are instant response. I'm on site when the contractor says, hey, how do you interpret this? You know, or this dimension doesn't work out. It was a busted dimension. What do you want to do? I'm right there to say, well, according to ProAg, it's got to be this wide, so we got to go this much further, or it's got to be this deep. And you're getting instant response. So with the contractor and me being on site full time, we got answers to questions immediately. There was instant direction that they could give, and there was really no downtime. Any time the contractor was working day to night, all day, every day, there was no downtime, no concerns or delays. Another thing, since I'm there all the time, my job is to make sure that it gets built correctly and on time and on budget. So inspections should almost always pass because I'm there. So as they're paving it, as they're forming concrete, as they're pouring concrete, as they're installing domes, as they're painting, I'm there watching them do it. And if there was any issues or something that I saw that they were doing incorrectly, I was there immediately to say, hey, while that concrete's still wet, fix that because that's not going to pass. Or the asphalt, you know, when they're out there, because these stalls have to be flat. This is an ADA accessible route, so this has to be 2%. So as they're out there with the paver and the roller, I was walking behind the roller with a level, making sure that everything was good. And if there was any locations that were not level, I'd point at the roller and have him come over and fix one spot. Little things like that saved both time on the contract overall, and then saved the contractor a lot of money. There was a lot of times where I saved them a bunch of money out there just by spot checking as they were following, as I was following their work. So overall takeaway, everything went a little bit faster, a little bit smoother than a standard construction project, I'd say, just because I'm there all the time.
Hey,
So
Cody, before
yeah,
you move on to the next slide, I did notice that there are a couple of questions about some of your earlier slides.
perfect. Yeah, I
If
didn't
you,
get any pop-ups. So yeah,
yeah.
feel free to let me
um,
know.
so Mike had a couple of questions. His first question was, does the number of accessible parking spaces in ProWeg agree with the Oregon State Building Code? And then he also has a question about, can you discuss the use of the raised flare versus leaving the area level with the rest of the sidewalk?
Okay. So the Oregon Building Code portion, I am not 100% sure. My understanding of the building code is more inside of structures, not necessarily outside in the public right of way. So we defaulted to ProWag for all of our dimensions and our design. I could be wrong on that, but I'm not familiar with the codes as well as the federal guidelines. So we stuck to that. Talking about this flare, I mean, yeah, we could have totally left it flat. What happened was the contractor had already ordered the mud and it was on site, so they already had enough concrete set up to do a flare, and they didn't want to send back a third of a yard or a half a yard of concrete back to the site. So we said, well, let's just elevate the whole thing and make it a little barrier to wander around. Like I said, I could go either way, whether it's totally, when it's all flush, pedestrians can walk down the sidewalk and they can come to this point and turn left or right. But having the barrier there, you could probably argue that maybe it helped with some of the water. You can see that there is standing water here. That was because this line here was plugged. I saw that after it rained. I had the contractor come out and saw cut that and got the water out of there. But that's about it there. I mean, you could go either way. That was just what we had with the materials and the quick decision we made on site. That was what we did. We got some other questions?
Nope, those were the two that we have so far, but it's a good reminder to folks that if you do have a question, feel free to use the Q&A chat box or to raise your hand.
Yeah, totally. I'm totally okay with stopping everything and visiting. So that sounds good. Next slide here. Let's see. This is about, so this is kind of our final takeaway from the project. And we could talk about this slide here probably all day. Starting off, what we think helped a lot in the beginning was the design time was reduced. So comparing a field fit project versus a survey project, they both have pros and cons. If we were to do a full survey for the entire project, for the entire site, you'd be looking at probably 2 to 3 weeks of survey in the field nonstop. You'd probably have another week and a half, 2 weeks maybe of office time, creating all of the surfaces for all of the lots, all of the line types, break lines, generating an accurate surface. This is all on the surveyor side. And that doesn't even count getting quotes for the survey, getting a surveyor under contract, doing all that stuff, figuring out what their schedule is to get them on site, do all this work. So now they've got a survey, they send it to us, unless your Keller Associates in Idaho, where they have their own surveying office, we don't out here in Salem. So we send out 2 or 3 proposals, or we get proposals from 2 or 3 surveyors that we use a lot, and they do everything in their standards and their line work, and then they give it to us. So then we have another probably 2-3 days, probably this size of a project, we probably have 3 or 3.5 days of going through their survey, vetting everything, making sure that the surfaces are really good, deleting points, because not every surveyor gets the surface perfect, so we always go through and double check it. Then you're going to have converting all of the line work, all the line weights, the blocks, everything to get it into a file that we can start to design with, to where everything is in our standards, to where it looks the way we want it to when we get it to the client. So that being said, you're looking at probably a month, a little bit more than a month of just time spent and money spent dealing with surveyors and getting everything into CAD where you can start designing. Instead, we did all of that in about 4 to 5 days. So we were out there for 3 days the first day, and then we made a second trip to another 2-day trip. I think it was 2 or 3 weeks later. And then the miscellaneous time we spent in between in Google Earth getting everything drafted up. So we can argue that the design time was totally faster from when we signed the agreement to when we had a complete set of plans. That being said, we have what you sacrifice in design time length, you lose in detail, obviously, because we don't have a survey. So our plans aren't going to be as detailed to the level that we want them to be, but the plans are at a point where it's totally constructible and it saves money and saves time on the client when both budget and timeline were our major constraints. So there was that little bit of speed. As we talked about before, construction administration was more responsive because I was on site full time. I was able to speed all that stuff up a lot faster. Let's see this one here. This is kind of a little bit of a different topic. So there was worries in the beginning about would there actually be cost savings on a project of this size? And this project proved that there was. That being said, in my personal opinion, these projects, these field fit kind of design build projects, they work excellent on super small projects, which is the next bullet on the $100,000 ODOT SCA grants. A lot of my job is working with small communities, applying for grants that are around $100,000, and then trying to get a project that they want delivered at that price. So when you look at, okay, a client gets $100,000, about 8 to 12% of that's engineering fees. You're going to have 15 to 20% contingency. Then you only have about $60,000, $70,000 left that the client can actually use to build their project. So on top of that, if we were going to get a survey, you're looking at another $2,500 to $5,000, depending on the size of the survey that you're going to need. That really cuts into your price. On these smaller ones that we've been doing, this year is the first year in the last 4 years doing SCA grants that we've actually got a survey on one of our SCA grant projects, because they're all so small, they're so flat that I know what I'm doing in design. I can put it together, I can lay it out correctly. I get a contractor on board that I know, and I go out there with them and we design it in the field and get it built, and we save a bunch of money, a bunch of time, because we're not spending so much time on design, we're not spending so much time getting survey. When they're it makes more sense. Why waste the time and money on a project that it doesn't need that much headache? If you can look at something and say, this is totally doable, the risk is low, let's just get a contractor on board and come out here and do this work. And that's how we've been doing it. And we've upped the project costs from $55,000, $60,000 to $90,000 that these communities are able to actually spend on their projects. So we've had a lot of really good success doing that on small projects. And even ODOT is starting to get into these pilots. They've had a couple pilot projects in the last 2 or 3 years where, typically they've done full survey on 1 or 2 ramps that a guy could go out there in an afternoon and paint out and stake with a contractor and design, and it'll pass their inspection. And they're seeing that. So there's been a couple pilots going out. They've actually had really good success. So who knows? Maybe in the next couple of years, ODOT will start doing more of these design build style field fit projects on some of their stuff. Last little item here: most of the work on the overall project overlapped. So a lot of the design time was still the same. A lot of the design cost, the level of effort, that was all pretty much the same. The major balancing points between the two was the time and the cost of the survey up front, and then during design, and then during construction, you've got the time and the cost required for an RPR to be out there on site with the contractor every day. That being said, the RPR is not there all day, every day billing full time to that project. While I was on site, I billed probably 3 to 5, sometimes 8 hours a day to the project. The other time, I'm in the car on my computer working on other projects on a Wi-Fi hotspot the whole time. So just because I'm on site, I'm really only on the clock for this project when the contractor needs me to do something. So that being said, you're looking at in the beginning of a project, you've got about 40, 45, maybe $50,000, including the engineering markup for a survey to manage the subconsultant and get all that work in there, versus having someone full-time during construction that we billed out to the client about, I think it was just under or just over $39,000 for full-time RPR services for 2.5, 3 months that I was out there. I was out there a lot longer than that, but 2.5 months was the meat of the construction. So the cost savings you're looking at is primarily that, the difference between the survey up front and then the full-time RPR in the back. So if you've got a lot of money up front in a survey that can totally be done reasonable, just field fitting with a guy and a contractor that knows what he's doing, or gal, during construction, then you're better off. It's a no-brainer. It makes a lot more sense to do it that way. So at the end of the day, we think that we got a much faster project. We had a lot less paperwork, a lot less work up front, and the construction either ran at the same rate or a little bit faster than a surveyed project, because the contractor could only work so fast, and I was there solving problems as they were going. Project was probably just as fast as normal. We're
Hey,
coming up
Cody.
on time. Yeah.
Yeah. So Bryce wanted to know, because your last slide was talking a little bit about ODOT and some other agencies. Do
Mhm.
you know of agencies that are doing field fit projects that are not on flat ground? It seemed like this was key on this project and not much flat ground where he lives.
I understand that, and we've done. It depends on. It totally depends on where the project is. That being said, on these SCA grants, not all of them are flat ground. We've done 2 or 3 in Amity that are generally flat. The last 3 that we've done in Willamina were not flat at all. They were on the gnarliest hills in the town, and just because the site isn't flat, what you got to try to do is figure out, okay, where is the flattest spot of this not flat spot that I could design something. So one we did out there in Willamina, we had a hill that was really humped, and we knew that there was no way, based on both right-of-way and existing utilities and poles on a $100,000 budget, that we were going to be able to relocate utilities and do all the work to actually construct the ADA ramps the way that they should be. So we still needed a crossing, so we added a mid-block crossing, and we just put that mid-block on the apex of the hump in the road, and that got us to where we were as flat as we could. And then knowing your grades, if you know that you have an 8.3% max slope coming into a run, 8.3 is 6 inches and 6 feet. So that's where you're absolutely maxed. You can't be any steeper than that. So instead of being 6 feet, go 7 feet, 8 feet, 9 feet, flatten out that ramp as long as you can to get your slope down. And then when you're out there in the field, I mean, I'm not just looking at a project and saying, oh yeah, that'll work. I'm out there with a wheel and a tape and a level, and I'm trying to, I even bring out a survey rod, and I survey some stuff and make some notes on paper and try to get it figured out. And the time that it takes me to do that stuff is still way less than having a surveyor come out at time and at cost. So sometimes it's not totally feasible, but when it makes sense, when the topography is a little bit easier to work with, it's worth considering. I mean, that's what I'm trying to do on this presentation, is just convince some folks that it's doable, and if it makes sense on your project, it's worth doing. It's worth pursuing. Was there anything else that came up? Any other questions?
Nope, that's it for now. Thanks.
Okay. All right, and we're getting here at our time limit. These are just my last 2. I got 1 slide, then questions next. So this is our lessons learned takeaway. Major things like we talked about: drone images and scaling. Get directly above it. Get zoom out a little bit. You can always zoom back in your photo editing software later. Make sure that you get some kind of scaling in your photos. It's going to save you a bunch of time later when you're scaling your documents in CAD to get more accurate quantity takeoffs. Specification language is absolutely important when you have projects that are a little bit higher risk, like this one is, where you don't have direct survey telling a contractor where to install things. When things are ambiguous, you have to add language that protects you, or it puts the contractor at fault if anything is done without client or RPR sign off, things like that. Remember, just like any other construction project, not everything's going to go according to plan. There's going to be issues either going from 2D to 3D, or there's going to be unforeseen circumstances in the field where you hit unexplained utilities or things like that. But that's just something that comes along with the project, whether you had survey or not. Last thing is always stay positive. At the end of 2.5, 3, 4 months of summer on asphalt in 100 and something degrees with a contractor that I've seen every day for 6 days a week, because we did a lot of paving on the weekends, we were getting tired of each other, and we were getting tired of the projects and tired of always having to come up with our own solutions because the solution wasn't in the plan. The key is just to stay positive. There's always an answer. There's always a way to go. Don't get an attitude where it's like, oh, that's not possible. We can't do that. We can't do this. Say, yeah, we can. We're going to get this done. We're a team. Engineer, contractor, owner are all on a team. We're going to come out here. We're going to kick butt. We're going to get this project done. That's the attitude you got to have. And you got to stay positive as you get through it. As you start getting negative, you get we got in a couple arguments and some stuff on site. We walked away from each other, came back. We said, okay, now that we got that off our chest, how are we actually going to fix this? How are we going to get this grade to work? So that is that's a majority of what I got. I mean, I hope that was helpful. It was kind of long-winded, a little bit over time, but feel free to reach out to me. I had my information on the first slide. Feel free to give me a call or shoot me an email. I've got that's my office phone, but here's my work email. If you need support or have any questions or have some projects coming up that's like, man, I wish Cody what would Cody do? You know, I'd be glad to help out. You know, I'd love to help you guys out on this type of stuff. These projects are my heart and soul. This is what I like to do. I don't like easy projects. So thank you guys for having me here. I appreciate it. Thanks, Jennifer.
Yeah, thank you, Cody. So we do have a few more minutes here that we could take some questions. Mike wanted to know, do you have a model spec that you would be able to share?
So this project was unique for like the ODOT and the SCA grant stuff that we do. We use the Oregon Standard Specifications for Construction 2021. This project is a little bit different because it was client-driven specs. So they had their own specifications that we had to write and augment. They were actually specs used for architectural projects that we had to convert into a civil project, which had its own issues and the major complications was when it would say something in one spec, in another section it would contradict itself. And even though we spent a bunch of time going through there and vetting that, there was still a couple spots that we missed. So I wouldn't advise sharing those specifications when I'm not totally comfortable with them. Really the only other spec that we use is just the OSSC and boilerplates. I mean, I start with a fresh boilerplate on every project. That way I don't have lingering ghosts from other projects when you keep using the same specs over and over again. But I just try to remember, okay, what burned us on that project? You know, I need to add a sentence here and there. Like I said, feel free to reach out to me and I can give you a list of some of the things that I write down in both my specs, general notes on the plans, and general note callouts, and specific things like making things incidental saves you a bunch of time later trying to measure things that are often unmeasurable. Just little quality of life improvements that you can make. So feel free to reach out to me. I can help you guys with that stuff.
Yeah, and I remember in your presentation, you talked a little bit about just some kind of boilerplate language that you put in around field fit and that. I also see that you got several kudos of great presentation. So
great.
Good job on that. There is a question here from Raphael asking, how hard was it to achieve a 2% grade with AC?
Very hard. Laying the asphalt at less than 2% wasn't an issue. It's when you're rolling it. A lot of these parking stalls that we had were confined on 3 sides by curb and gutter. So as you're rolling back and forth, the roller is not going to get the last little bit and it starts to shove and it pushes a little bit of asphalt up around the edges. Solutions to that stuff is, while it's hot, have guys there with tamping it down, flattening it out, vibra plates, whatever you can to try to get it flat. It's really about just pounding the asphalt and keep going over it and over it and over it until you're absolutely positive that it is to grade. And that was when with asphalt, with concrete, you're supposed to use a 2-foot level. With asphalt and it being parking lots, not necessarily a sidewalk, we gave contractors some slack. I used a 4-foot level on that stuff during my inspections. And I just followed the roller and I said, no, it's not level here. You need to roll on that side more. Then he would roll that and I would check it and go back and forth until it was totally good. We did have one lot that they didn't, they paved it without me being there. And when I came back the next day, I saw it was paved. I told them that I wanted to be there when they did it. And I went out there and I measured it and it didn't pass. And they had to tear all that asphalt out. And the next Saturday, they came in and repaved it at their own cost. So the one time that I wasn't there, we did have an issue. But as long as you're there checking it, it takes a lot of micromanaging, but it can totally be done.
Who was your contractor that you worked with on this project?
It was Wildish Construction out of Eugene.
Okay. And there's more kudos for you. I also, let's see, I thought that, whoops, I thought we have a hand raised here. So let me see if I can pull that up. So Katie Marwitz has a question. Katie, I've allowed you to talk if you want to unmute yourself and ask a question. Katie, are you there? Okay, well.
That's okay.
That's okay. Let's see. I think I have some more questions here. Let's see here. No, more kudos for you. So we just have maybe a minute left here. So if anybody else has another question, oh, let's see. I have another raised hand, it looks like. Mike, I have allowed you to talk. If you'd like to unmute yourself, you should be able to talk to us.
Can you hear me?
Yes, I can.
Yes, sir.
Very good. Nice presentation. Well done. Thank you. Just on the parking piece, so people are aware, there is a code, building code for Oregon. I'm pretty sure it aligns with the numbers that you had. I think that's where we pulled it from. And then Oregon Transportation Commission, so through my shop, is required to put together the striping arrangement for accessible parking in Oregon.
Mhm.
And the people might be aware that that resource is out there. And if you Google ADA accessible parking standards Oregon, it'll come right up. It's the approved version of signing and striping
Okay, great.
through the commission and
So
through
that
the
has,
Commission for the Blind.
so
I
that
mean,
has, that would be stall widths and lengths and van accessible widths and lengths with signing and the required approved handicapped and van accessible signs, or
yes.
what is the code referencing? Okay,
Yes.
cool. Yeah, I would think it would be the same. I'll verify with that after the fact, but I'm sure that would be the same as the ProWag.
It's just a good resource for anybody who's doing site work like that. So
Absolutely.
thank you very much.
You.
I really appreciate it.
Yeah, thank you.
All right. Thank you, Mike. So I don't have any more questions in the queue here. And so thank you again, Cody, for joining us here today. It looks like there was a lot of interest in this presentation. I did record this presentation and it will be available on the Oregon APWA YouTube channel if folks want to watch it later. So thank you. And I guess another reminder, APWA Spring Conference next week. So go to the Oregon APWA webpage if you want to learn more about that. And then I think the next presentation is in 2 weeks for Lunch and Learn. So thank you, everybody.
Thank you. Glad to share. It was a lot of fun. So look forward to hearing from some of you guys.
Thank you, Cody.